Hi, everyone. Welcome to my talk. I'm Dawin. I'm an independent security researcher from Germany. And I will be talking about KakaoTalk, which is South Korea's biggest mobile chat app. And I have structured my talks basically into 4 parts. In the first part, I'm going to talk about what KakaoTalk is all about, the recon phase, basically. Then I'm going to talk about a one-click exploit in KakaoTalk, basically that allowed me to take over another user's account and steal all of her or his messages. Part 3 of the talk will be about KakaoTalk's end-to-end encryption feature, which is called Secret Chat. I found a couple of protocol weaknesses here. And then in the last part, we'll just conclude. So expect a mix of Android AppSec, Applied Cryptography, and web security. So it's like a bunch of everything. All right. So what is KakaoTalk all about? As I said, it's like South Korea's biggest mobile chat app. It has more than 100 million downloads from the Google Play Store. And I think it's like, 41 million daily users in Korea. So it's basically the WeChat of South Korea. In KakaoTalk, you have multiple different chat rooms. You have regular chat, team chat, secret chat, and open chat. So multiple features to basically interact with different people. It's like a so-called super app, I would call it. Like for many other, you may know also like WeChat. Like they have a bunch of features like ride-hailing, payment services, and like a lot of stuff. So they bundle a lot of different functionalities together. So that means that the attack surfaces are quite big. So you're going to find like a lot of bugs when you just, take your time. In this talk, I'm going to focus on regular chat and secret chat. And I took a look at the non-Korean Android version of the app last year, which is version 10.4.3. KakaoTalk is based on the so-called LOCO protocol. It's a proprietary protocol made up by Kakao company. And LOCO is presumably an internal project name, so it's not like the German chicken brand, LOCO chicken, or the Spanish word that means crazy. It's a really, really simple protocol. It's just based on top of TCP, and they use a binary JSON. So it's as the name suggests, just JSON in the binary format. And the message payload is basically encrypted with an AES key that is shared with Kakao Corp. So that's all about it. And they use a typical messaging store and forward messaging architecture. So that means that there's a server in between, so no peer-to-peer messaging or stuff like that. So that means if, for example, in case the other recipient is offline, the server would store all your messages, and in case the other party goes back online again, the server would just like forward the messages to you. So like a very typical architecture. And then there was like a Korean researcher called Brian Pak, and he basically reversed most of the protocol back in 2012. And since then, the protocol has changed very much, not very much. So they just added more functionalities to the protocol, but the core principles are still the same. That's an example of one of the packets. You see like in line 8, this LOCO command. So that's how the protocol basically works. You have like a specific command that is tied to each action. And in this example of the screenshot, you see like this SWrite name. That means that an end-to-end encrypted message is sent here. So you see like in line number 2, the body payload, and there's like some base 64 encoded strings. Those are basically the messages. And then you have like some simple header fields and stuff like that. So it's pretty much straightforward. Since the protocol is pretty basic, it has a couple of really basic flaws as well. So I would say the first one would be that there's no server authentication at all. So unlike, the HTTPS protocol, where you usually have like some TLS server that would present you like a certificate to make sure that you're really talking to the server that you want to, they don't have such a thing. So potentially you could man in the middle of the communication flow without being detected. Also, there's no ciphertext integrity, so they don't do any integrity checks on the ciphertext. So potentially, as a man-in-the-middle attacker, you can tamper with the ciphertext without being detected. And since they use a so-called malleable block cipher mode, in that case, they use the cipher feedback mode. If you know parts of the plaintext, you could do targeted bit flipping attacks, and this was exploited multiple times in the past. For example, like maybe some of you know the eFail attack from 2018, where some guys attacked the PGP implementations of email clients. And by just flipping bits, they could basically steal PGP encrypted messages from the user. Yeah, last but not least, there are no replay attack preventions that any protocol should basically support. So by just poking at the traffic a little bit, I was able to replay messages, and that was happily accepted because they don't use any nonce or any freshness values that would counter that. Yeah, as I said, I poked at the protocol a bit. So all the man-in-the-middle proxy POCs that I have, I put them on my GitHub if you want to check it out. All right, so that was like the basic introduction into KakaoTalk. Now I'm coming to part 2 of my presentation, which will be a one-click exploit to steal another person's messages by just clicking a link. Just quick intro again about the regular chat feature. So that's one of the chat rooms that KakaoTalk supports, and it's for one-on-one or group messaging, and it's the preferred way for many Koreans to use this app. And it uses the LOCO protocol that I just introduced under the hood with all its flaws. And there's no end-to-end encryption by default. So all messages could potentially be read by the company, right? So unlike in I don't know, Threema or Telegram, WhatsApp, Signal, you have end-to-end encrypted messages by default. Here, this is not the default. Yeah, I told you previous guys, that KakaoTalk is like a super app. So it has many features. And that's where I also found the entry point of my exploit chain. So it's not like in the chat functionality, but it's like in their shopping features. So that they have like a web shop that you can use in the app for shopping. And the implementation is pretty straightforward. So what they do, they just they have an exported web view. So that's like a way of in Android to show like web pages to you, and they just render this website buy.kakao.com in that particular web view. And in Android, you have a thing called deep links. So that's a way to basically open app components by clicking a link on the app. So if you would click this KakaoTalk link here, /buy, then you would end up opening this web view basically. And the nice thing about this activity is that it has JavaScript enabled and that it supports the intent scheme. So the intent scheme allows you to reach any other non-exported app components via JavaScript. And this has been also like exploited in the past a couple of times. And there wasn't any sanitization of intent URLs whatsoever. But I didn't exploit this fact in my exploit chain. Yeah, but the bonus of all this is that the web view leaks an access token in the HTTP authorization header. And basically now the goal for me was, okay, this was the entry point, and the goal was, okay, could I somewhat steal this token from the user? I told you guys that you could potentially open this activity by clicking this deep link. But of course, they had some validation going on for validating deep links in the app. So as I said, they basically render buy.kakao.com in the app. So they did this like in the header of this function. And what they also do correctly is what you should always do on Android to validate the scheme and the host components of the deep link. So this is very important. And they did this as well correctly. But then what they do, they basically concatenate two strings together. So they take this buy.kakao.com And then they concatenate it with the path, the query parameters, and the fragment of the URL. So and that's what we as an attacker can control. So to give you an example, at the bottom of the page, so if you would click this link, KakaoTalk//buy-foo, this would render buy.kakao.com/foo in the web view. So that's cool because we control parts of the URL, but not all of it. And the goal for me was now to basically run my own arbitrary JavaScript in the web view in order to steal this token. So, so I was like investigating buy.kakao.com for any XSS flaws because my goal was to run JavaScript. I also couldn't man in the middle the HTTPS communication. Of course, you could do that, but for that you have to tamper with the phone. So that wasn't an option either. But luckily enough, I found this redirect endpoint on buy.kakao.com. Here, this like clean front redirect endpoint. And that was cool because that redirected to any other kakao.com domain. And that vastly increased my chances to find an XSS flaw on any of the other subdomains. So, and that's what I did in the next step, basically browsing all of the subdomains of kakao.com and try to find an XSS on that. And for that, it's pretty simple, like using a Google Doc. You just basically Google for all sites that have kakao.com in the domain name, and maybe like a prominent like attack vector for XSS or search fields, right? So we just like include that in the URL search as well. And then you end up with a list of possibly vulnerable XSS websites. And yeah, I was lucky. I found this shoppinghow.kakao.com website, and it had like an XSS in the DOM. And I found this with Burp Suite's DOM Invader. It's like a feature of the Burp Suite tool to basically find DOM XSS flaws on websites. Yeah, I found this flaw, and then you see that in the fourth bullet point, like really pretty simple XSS payload that I just like used. And the result was with all that I could run my own arbitrary JavaScript in the web view to steal the token. Yeah, that's the final big link, basically the payload that I would send to the user, like the clickable link that I would send to them. So you see it basically from line 7 until line 10, 4 different parts. So the first part is the deep link itself, the KakaoTalk //buy. Line number 8 is the redirect endpoint in order to redirect to another vulnerable XSS site. Line number 9 is the vulnerable XSS website. And last but not least, line number 10 is my final payload. And this JavaScript payload basically lets the web view connect to my own server so that I can get the access token, because the access token was leaked in the HTTP request error. Yeah, just to summarize again, to break it up a little bit more, the final payload. As I said, first the deep link fires up the vulnerable web view. Bullet point number 2 is the redirect, because as I said, we control the path component of the deep link that would basically redirect to this website. And last bullet point had the XSS flaw. Right, final XSS endpoint, payload. And you see here in the add top basically a function which is like for decoding base 64 strings, because I had to base 64 encode my server URL for some reasons, because there were some checks going on. Yeah, so with this final deep link payload, I was able to steal the user's access token and send it to my own server. So the question was, now I got this access token, what could you potentially do with that access token? And I was able to use that token to take over another user's account by registering an email address for that particular user. And the cool thing was that this would also overwrite the previous email address that was registered with that user. So that was pretty neat. And having access to the email address of the user or the email account the next logical step was to perform a password reset, right? Just to get the user's password and to take over the user's account. Yeah, there was like, for the password reset procedures, there were some client checks going on the website, but that also could be bypassed pretty easily with Burp again, just by intercepting some requests, changing some request headers, and yeah, that was pretty straightforward too. All right, now to give you like a quick summary of the final POC, so a couple of steps. So first, what I'm doing in the POC, which I'm just about to show you on the next slide, I'm starting a HTTP server that would serve the malicious deep link, like the big one that I shown to you previously. In the second window, I just start a netcat listener for grabbing the access token from the HTTP request. Then the victim clicks the link, I get the token. Next, I'm resetting the user's password. And then the attacker could register like his own device to the user's account, and then all the messages would be synced to the attacker's account. Even though there was like a second factor involved, so if you register like a new device to your phone in KakaoTalk, you need to enter also like a 4-digit PIN. I couldn't brute force that because there was some rate limiting going on the backend side. But again, easily when you have the access token and with the right curl command, I was just able to get this PIN from the backend, but by just asking the backend for the PIN. That's what you see on the screenshot. All right. Okay. Maybe like that. Let's see. Oh no. That's what it is with demos. All right. Anyways. Okay, in the demo, what you would see is like a video that I pre-recorded. Basically like a couple of windows, a guy using the link, clicking the link, and me reading his messages. I have some URLs in the end of the slide that would, give you like, I'm gonna provide a link to my blog, and then you can watch the video on my blog. For some reason, it's not working right now, but it worked before. All right. Nice. Damn it. Okay. Yeah. On the browser? Maybe I try it after the talk. I just like, let me continue, and then maybe like by the end we have some time left, I guess. Then I can figure this out. All right. So this was part 2. Like I was talking about the one-click exploit now. I found an issue there. And now, like in the third part of the presentation, I'm talking about KakaoTalk's end-to-end encryption feature, which is called Secret Chat. So yeah, that's a dedicated chat room in KakaoTalk for end-to-end encrypted messaging. So it's an opt-in feature. So you have to create that chat room in order to message securely with your counterpart. And like a quick history of that feature was that it was added in 2014, and that it's based on the existing LOCO protocol. Because in 2014 there were like big demonstrations going on in South Korea because of some huge ferry disaster, and then the Korean government spied on some of the protesters and collaborated with the KakaoTalk company, and then this got revealed. And then a lot of users left KakaoTalk to more secure messaging apps like Telegram. And then in order to react to that, KakaoTalk came up with this secret chat feature like within 1 month or 1.5 months, just to get users back. And the only big change in this chat room is that they encrypt the messages with an additional key that supposedly shouldn't leave your device, so that the server cannot sneak on your messages. And they also put a MAC on your message for integrity protection. But the odd thing about this secret chat feature is that it doesn't support voice calling and has the other features of the other regular chat room. So my assumption is that not many people really using it because it doesn't have the same feature set. Yeah, so I told you guys that we use a different key, like a second key for encrypting messages, but this key has to be delivered to the other party somehow in order that both parties can read and write messages. And for that, they use a really, really simple key exchange mechanism where they just basically grab the receiver's public key, RSA public key. They take this public key, encrypting a shared secret, and then sending this over to the other party. And then the sender is basically able to decrypt the shared secret and compute the same end-to-end encryption key. So both parties have the same key and can talk to each other. But yeah, as you can see, the key exchange is not ephemeral. So it's static and pretty simple. Yeah, and you know from TLS servers or server certificates that public keys have to be trustworthy. So you have to make sure that the public key really belongs to the intended person. And usually, like in the world of PKIs, you have a like CA that would sign your certificate and make sure that you're really like the person that possesses the certificate. And you also need to have the same mechanism here for chat apps. So you need to make sure that public keys really belong to the intended users. And the way KakaoTalk does this, or most chat apps, they do it the same way. They run like an authority-based trust model. That means they run a database where they map the user's public key to their device identifiers, and they check the ownership of those keys during installation. So if you install the app, you sign in with your credentials, so something that you know, and then there's also like a second factor that you like something you possess basically, and for this second factor they use they send you a PIN code via SMS. And this way, the app makes sure that the public key really belongs to you. But there's a problem with this server-centric approach. Like for most chat apps, they maintain this database of public keys. That means like an attacker some attacker with access to the server could compromise the database, right? And can inject their own man-in-the-middle public keys. So that's why it's super important, guys, that you always check your public key fingerprint in the app. And usually how this does for most chat apps, you just scan the other person's QR code and then you verify it whether this person is really the person you're talking to. But yeah, normally nobody does this. And maybe like from, I don't know, WhatsApp or Signal, if the other person reinstalls the app or has a new phone number, then you get those short messages like saying, well, the security code has changed. That means that the public key has changed. Yeah, what are the weaknesses of the end-to-end encryption protocol in secret chat? So I think the most obvious is it's not enabled by default. So it's an opt-in feature. You have to actively create this chat room in order to chat securely. Unlike for all the most other chat apps where you basically have end-to-end encryption by default, you don't have it here. I talked about the key exchange, that it's not ephemeral, it's really basic. And that means it doesn't support forward secrecy. If you think about most TLS cipher suits, they all have forward secrecy enabled by default, just the way the key exchange works. And similarly, there's no backward future secrecy, which is basically the opposite case, and which is implemented in the Signal protocol for the Signal messaging app, and the algorithm is called double ratchet algorithm. Yeah, and then maybe another more obvious weakness of the protocol is that there's no independent audit. It's not open source, and there's no open documentation. That's also a key requirement, I would say, for secure messaging protocols, that they're open, accessible, and that everyone can review them. But that's not the case here. Yeah, and last but not least, secret chat is based on this LOCO protocol, just added basically on top of it. So it inherits all of those protocol flaws that I mentioned earlier. For example, no replay prevention, and there's no ciphertext integrity, which is also a basic feature for most protocols. Yeah, just like to show you like a proof of concept. This hopefully, I think this works this time. Yeah, I added screenshots so of the video. So and that's a proof of concept just simulates the scenario of a compromised server. So that would affect any other chat app as well. So that's not something unique like for KakaoTalk. I just made this up for poking at the traffic and to show you guys. So it's like not a concrete vulnerability here. Yeah, the POC works in 4 steps. Basically, you see it on the screenshot at the bottom of the screenshot. The first thing I do here is to man in the middle of the traffic with man in the middle proxy, and inject my own man in the middle public key. Classic man in the middle attack. Next, I'm trying to remove any previously exchanged shared secret just by dropping this message. Yeah, and then the sender would basically use my man in the middle public key to encrypt the shared secret and send it over. So, and since it's encrypted with my man in the middle public key, I can grab the secret, decrypt it, and yeah, re-encrypt the same message with the receiver's public key. Yeah, last but not least, because in this, the last step would be I have the shared secret. I can compute the end-to-end encryption key and yeah, just dump the messages to console. The last 2 messages here in yellow, you see that I type some messages in secret chat and you can dump it to console. So yeah, that basically shows the scenario of a compromised server. And also it shows that there's no integrity protection in the ciphertext, right? Because you can tamper with the traffic. And there are no integrity checks on the receiver side that would drop like malformed or like modified messages. Because that's not in place, I can do this man in the middle attack. Yeah, and this is a GIF which works now. Yeah, just like a GIF demo to show you the man in the middle proxy POC for logging and poking at secret chat messages. Yeah, coming to the basically conclusion. I disclosed the one-click exploit in December last year via KakaoTalk's bug bounty program. And yeah, the funny thing was that the bug bounty program is only entitled for Korean citizens and they don't pay out to international researchers. So that was a bit funny. Yeah, this like vulnerable commerce spy activity that I mentioned earlier, it was removed from the app. And also this redirect that I used in the exploit chain was removed too. And the XSS flaw on the shopping website was fixed. Yeah, concerning the LOCO protocol flaws, I reported them back in 2016 because I did my thesis originally on it. I contacted KakaoTalk, but nothing happened. And now, like, I contacted them again in July this year, and they're working on fixing some of the flaws. Yeah, if you want to read it up, I put the correspondence also on my GitHub to put some transparency in that, so you can read it if you want. Yeah, lessons learned. For me, at least, I think there's like the most surprising was that there's still chat apps out there that don't need a complex exploit chain in order to get compromised and to steal users' messages. Unlike like for, I don't know, iMessage, where you need like a crazy exploit chain in order to steal messages, or like in WhatsApp, stuff like that. This was pretty simple. And the entry point was not in the chat functionality, but in some other functionality, like because of this big attack surface. So I found the entry point in the shopping feature and not in the chat functionality. And yeah, that in Android, that if developers introduce a couple of logic bugs in the code, as they did here, the security model of Android can be bypassed, and also stuff like message encryption doesn't help anymore. Yeah, and last but not least, I think super apps like KakaoTalk or WeChat are probably still a bit underrepresented in the research community. That's just my personal feel, though. So if anyone knows of existing research, please reach out. Yeah, and I hope that this presentation will encourage you guys to also dig into those apps, because there's plenty of attack surfaces. Yeah, that's it. So I put all the POCs on my GitHub. If you want to check it out, there's also like a full write-up of this presentation on my blog if you want to read the details. And there's also a working demo. And if you have any questions, like just come right next to me after the talk, or reach out to me on X. I'm here to like discuss with you about messaging security. Thanks, guys. Okay.
Thanks, Dawin.
Yes.
Questions, anyone?
Thank you for your talk.
Thanks.
So, if I'm starting my own chat app today, what should I use? It feels like all these vulnerabilities come from like lack of standardization. We have so many like chat apps, and everyone's doing their own thing. Like, what is the best practice in your opinion, or like in terms of standards and protocols, if I want to do my own chat app?
I would say I don't want to do any, marketing or anything like that, but I would personally pick the Signal protocol, because you can also run your own server. Because this is also forgotten a lot of times, that you also have to run your own infrastructure and not only the client app. So I would use the Signal protocol because it's open source and the server is also open source, and do it as WhatsApp. They use the Signal protocol, but they heavily adapted it, but they use it as a core protocol. I would start with that.
Thank you.
Yeah. Maybe meanwhile, if we have some time left, I can try to get the demo working.
Yeah, sounds good.
Or is there anyone can help me with the internet access, maybe?
In the meantime, as we're waiting for him, just like to gently point your attention to all that's going on in HITB, and that it's not only at level 4. So for those who have not been informed yet, we actually have 3 additional segments, and that's happening at level 2. So take the escalators 2 floors down. Once you reach level 2, straight and turn left. We actually have single player CTF. You don't have to register beforehand. You can register on the spot. In addition, there's actually 2 other villages, one being the forensics village, where they'll be discussing more in terms of the analysis of storage chips, dissecting drones, and exploring radio frequencies, as well as the FinSec village, so more in terms of DeFi technologies, tips, tricks, and tools. So that's happening at level 2, down from here, but still part of Hack in the Box events. So let's wait a couple minutes more. All right.
All right, so demo or get the fuck out. So basically what you can see here on this blurry screenshot, or on the video on the left hand side, is the victim's chat. So basically the victim I'm talking to. In the middle top terminal window, that's the HTTP server with which I basically distribute or serve that deep link. Bottom top, center bottom, is the netcat listener for grabbing the access token from the HTTP header. And right hand side is the attacker's device that I want to basically connect to the victim's account. So just let it run. The resolution is not the best. Right? Can you see something? Yeah. So I'm just like chatting with the victim. We'll chat. I will steal all the chat messages now. Okay, no problem. I sent the link. This malicious deep link, it's served by my server. The user clicks it. I see the GET request here at the top. And now, yeah, this web view leaked the access token in the authorization header. You see it also on the bottom. So I got his access token. Now in the background, the attacker can reset the user's password, take over the account. All right. I got the credentials and log into the user's account. Yeah, and that's the user's account. If I click, I see the chat history. And got access to all user chat. Yeah, that's it. Yeah, and as I said, you can basically, that's my blog. If you want to read the details, right, I can, yeah, I put also like the URL on my slides. And, yeah, like if you're interested in the details and stuff like that, because this was like a more high level presentation, you can read it. Right, guys, thanks.
Thank you.